Welcome back, friends. Welcome back to the homestead. Work continues on the smart greenhouse version 2, and part of that process is we need to be able to interface things onto the control box, such as LCD panels, TFT screens, switches, stuff like that. So I thought I'd include a video on that, as I've had some challenges along the way. I'll take you through that process. As you can see, I've not cut any holes yet. I've been working out how to do that. So the first thing I want to do is kind of jump on the computer and show you what I did in terms of designing the interface, and then how we work out how we get that onto here. Okay, so probably a good place to start is making a list of all what we need to interface and make holes for on the box, regardless of whether it's on the fascia, on the side, or the bottom, or whatever. And then the way I've done it is I've got the sensor listed, how many inputs it has in terms of connections, and the type of connector that I might use to do that. So this is the aviation 4-pin DIN plugs, which I did show in a previous video. I'll show them over here on the side. So they enable us to plug and unplug quite easily to remove the box. I think previously these were hardwired into the box. They're 4 pins each, and each require 3 pins. And then they're all inputs, obviously. Then outputs, with the exception of the door sensor, we've got control of the windows, which need a positive and negative feed for each. So there's 4 wires there. The pump and the exhaust fan, 2 wires each, so they can use one plug, and the intake fan uses 2, and then we could use the other 2 pins there for the door sensor. Hopefully there won't be a problem with that, because obviously there's one that's going out and that's going in, but I think that'll be fine. And then switches, we have, as listed here, things like 12-volt power, and they will be positioned on the top. 5-volt power, again on the top, and then I think it's better to have those a little bit out of the way, so having them on top, as I had them before, really, because most of the time they're not touched at all. They're either, once they're on, really. Because this time I've got different ways of resetting. I don't need to touch these switches really until it comes to taking the board back down again for winter. We've got some Wi-Fi skip and board reset switches. So the Wi-Fi skip is a straight, push in, push out, on off switch. The board reset is a momentary push button on the side. And then we move to the front panel. We've got then some rocker switches, straightforward rocker switches, as I used before, really, for board override, and basically all the overrides that cause functions to happen and outputs to happen, such as opening and closing windows manually. And then some other apertures we need to think about. We've got the 12-volt in, which again I'm going to use a slightly beefed up aviation 2-pin DIN plug for positive and negative, rated up to 30 amps. The others are rated up to 8 amps, I think, which is fine for the individuals. And then a fan. We need fan air intake, because the box itself is cooled with a small onboard fan. And then we need the aperture for the LCD screen, and we also need the apertures for 2 TFT screens, which I'll demonstrate. They're a little bit fiddly, actually. It's not a straightforward hole. Yeah. So and then once we've got that list, we can then work on design. So let's have a look at the design. This is just the front, which is what everyone will see is the front. The top, on the sides are a lot simpler. I mean, they are just holes and they are just squares like here, because they're rocker switches, or they're push button switches. I've tried to design or use objects which have their own, basically they hide the hole, so it doesn't have to be perfect, but I will try to make it as perfect as possible when I cut it. Come to that in a bit. Or I'm designing a 3D printed bezel. So for the LCD screen I've got bezels, and for these I've got bezels as well. For the TFT screen, as you can see, they're quite an odd shape and odd, how would you describe them, kind of, they're fiddly and they've got odd things that you need to cut out. So for example, where the pins come through, first of all, they won't be mounted under the box and poking through, they'll be mounted on top of the box and and going back down, and then the bezel goes over the top, a bit like this, as I'm showing you now with a plastic bezel. They require some cutouts for this bit at the top here, and this where the pins are soldered on the board as well. I guess I could resolder them all flush, but this is how it comes. Basically on here, the darker black lines require cutouts, and the other lines are either to get a shape or they require some work, because the component, it won't sit flush, but it doesn't require a hole basically. And then to get this, that's part of this really, is how do I get this onto the board. So that would be the next part. So I print this out on the printer with existing perfect size. In Adobe Illustrator, it allows you to design perfect millimeter size. And then I'll print out with no borders, and that will print out exactly on the sheet, as we can see here now. So this is the sheet, and then what I'm thinking with the sheet is I will just line it up centered and then tape it. But what we need to do obviously is, how do I get this design onto the box? So my thinking is, and I did a little test earlier, is I will hold this up to some lights, I will mark with a pencil around, and then when I turn it the other side and tape it, I will just rub it with a pen, go over with a pen, and then that will transfer the carbon graphite from the pencil onto the box. And I've tried a bit over here, I've rubbed it off now, but actually it's still showing a little bit. So that works well, and I won't need to, I will just do the corners really, and then I can go back with the pen, with a permanent pen, and mark it where it needs to be cut. I've looked on the internet how to do it, and I couldn't find any other better ways. Obviously you could use carbon paper, I suppose, but I haven't got a piece of carbon paper. You could laser cut it with CNC and stuff like that. I haven't got a CNC or a laser, so this is the best way I could come up with really. So let's move on and do that bit. Okay, so actually it turned out pretty good. It worked as a methodology, so I would approve. Whether you do or not, I don't know, but for me it was good enough. These holes were good enough. You can see it's a bit sketchy in places, but it's enough for me to be able to either follow or just correct the lines and then saw or drill or whatever it was. So it worked. So the next stage really is then to take this outside or wherever to the workshop and cut some holes and try and get it ready for fitting some of these switches and screens and whatever. Okay, so I've come out into the greenhouse because it's bitingly cold outside. The workshop is freezing cold as it's on a shaded side, and the sun is shining, so it's warm in here. And I built this potting bench last year so I can use it as a workshop desk. So tools wise, I use the drill to drill pilot holes, I suppose, or beginning holes. So then I can get a coping saw in. I've got this really wide, I think it's called a coping saw. So that will allow me to get into all the positions of this box, no problem. I use this on the other box, it's quite effective. And then for finishing, I've got some files, and maybe a knife if I need to scrape a bit off. Got this drill as well. I'm not sure if that's going to be as effective. Drill size doesn't really matter. In terms of this one here, this doesn't really need to be that precise, because if you remember, just needs to let the legs through. I mean, it doesn't need to be square. We're just getting these soldered pins through. So just need a few holes really, and then sort of chased across. And then that one does need a hole. These two, but these two, if you remember, are just those few components. Here, so they don't stick out, don't stand out very deep, but they'll need a little something here just to let them sit in, so this basically can sit flush against here. So I'll probably stick it on a time lapse, so I'll do that. Okay, that's done. It was a bit more difficult than I thought, as you saw, but I do remember these being difficult last time, actually. A bit fiddly. They are kind of there. I just need to... these are not the finished switches. The ones that are coming are supposed to be the same profile, but I think it's safer to double check when they arrive. They pretty much fit in. They just need some fine tuning. When they arrive, I'll do those. These, I just need to get the recess here correct for the small little diode that's on the board. It takes a little bit of fine tuning, but that'll be fine. What I had forgotten, it wasn't on my list I don't think, is I bought this USB plug, which I thought would be really neat to have on this box, the ability to plug in USB devices to charge them up or whatever, with the USB-C port as well. So I just need to do an aperture for this somewhere about here, I think. Because when the board is up here and I'm working around on the potting desk, it'd be quite nice to be able to charge my phone or whatever if I'm listening to the radio or an audiobook or something. So what I'm going to do is measure this up with my micrometer and see if I've got a Forstner bit the same size. If not, we'll have to think of something else. Okay, next we're going to move on to the actual box itself. Predominantly there's two or three things to do here. There's the power switches up here. There will be the side reset switches, or Wi-Fi skip switch, and then down the bottom I need to put the sensor and output connectors. These are the aviation connectors, DIN pin. I call them DIN pin, but I think so 4 DIN pin aviation connectors because they screw on, which will make it easier for me to remove the box without it being hardwired. So there's 8 of these that need to go on down here. I had considered offsetting them so they were like kind of this. I thought it might be easier inside, but I don't think it will make an awful lot of difference, to be honest. So anyway, we'll drill, these are 16, well these are the bit that, the panel mount end as it were, these mount on the panels. 16 mil these are. It's a very, very thin flange around it. It's only about 1, maybe 2 mil, 1.5, which obviously stops it coming through. So 16 mil these are to the flange, and then we'll screw those tight on the panel. Okay, so my bits and bobs are turned up. There's the front panel rocker switches, which we'll be fitting in a minute. I've got these dinky little push button switches and a momentary switch as well, which will fit in a minute. And I've also got this chunky 2-pin DIN power plug as well for our main 12 volt DC in, rated to about 30 amps, I think, 35 amps, I can't remember now. So, and we'll get that fitted down here. We're going to do that first, and I think then we'll do the side ones, and then we'll get the front panel finished by fitting those rocker switches. Lovely job. Right, now that's done, I think we can move straight on with getting these rocker switches in. I need about a clearance of about 10 mil width and 27 mil to get these fixing blocks, locks, tabs in place, and they hopefully will go in roughly with a bit of a shove. Now, one thing to point out here, in the UK we push down for on, but in the EU, in Europe, they push up for on. I don't know how it is in the States, maybe let me know in the comments. Now when you get printed switches, as I've used on the top, they're printed with on and off in the only way that you could do it. Obviously 1 and 0 could be used either way. I'm tempted to do it as UK actually, with the one, to push down, flick it down for on. But I appreciate that my EU friends might think I'm doing that wrong, but for me it feels right. So I'm going to see if I can get these pushed in. Lovely job. The last thing to do actually is to fix our panels, our TFT panels and LCD panel. We'll wire them in the next video, but for now, as they're part of the panel, and also have a quick talk about these 3D printed bezels that I've printed. So these need fixing down with some super glue or something. And then on the other side, we use these JST connectors. Okay, and then for the LCD screen, I can't fix that at the moment because I need to change possibly some of the wiring. But I've got this dummy module which is actually broken now. But what I can do is fix the bezel in place. So we use the dummy one to squeeze into place. Put something underneath to hold it there. And then the bezel we can fix in place. There we go. Because these have got the plastic rip-off, I'm not going to fix these bezels into final position until I'm ready to go really, and I'll peel those off. But there we go, there's the front cover done. I'll just talk quickly about these bezels on the 3D print to demonstrate the difficulties in actually making these, and then make these available. Okay, so if we look at the little TFT round display, which is the GC9801, first problem is there's many different variations of it, and I'm guessing over the years they've changed it, and also there are variations depending on when you order it from. If you take a look, that doesn't look like mine. All the circuitry's on the back. That one. This doesn't look like mine. There's no board visible at all. This one has a little board, but that's more like mine, this one. Some you can see don't have any board. some don't have the holes, whatever. So it's three or four different variations. So I was hoping, and there's people selling the beazles on Etsy, which they're not appropriate for mine because of the shape. If you look on Thingiverse, which is the 3D print model library, I've got some stuff up on here as well, and this is where I will load my version. You can see things that look like it. I'll come back to this one, and you know, cases that would hold it and mounts and stuff like that, but there's no beazles as such apart from this one, which was the nearest thing I could find, but it wasn't designed for the board that I've got. So what I did was downloaded this one initially, printed it off just to check that it wasn't going to work, and there were a few things wrong with it. But let's load it up into Blender. So this is that one in Blender. I didn't want, I already planned to glue it onto the fascia. I wasn't going to screw it down. There's no point having it screwed down really. It was the wrong shape anyway, and in addition my board, as you can see, has some pins that needs to be accounted for, and it had a little tab stick out at the end that needed to be accounted for as well, and needs to be recessed to fit on over the top of the board and onto the panel. So if we look at my design, initially I took this one, it's very roughly based on that one, filled in the holes, extended it, played around with it. To be honest, I made so many changes to it in the end I should have just started from scratch. But anyway, here we are. You can see I recessed it, or rebaited it, put the rebate and the recess in for the pins to stick out, the soldered pins, and then the other end put it, shaped it here for that little tag stick out bit on the other side. Reshaped it and smoothed it a bit to look a bit nicer. Obviously it sits a lot higher than the other one. And then printed that off, and then here we are. So I'll stick this up on Thingiverse. If you've got the same board as this, then and you want to flush mount it onto the panel like I have, then you'll need this. So I'll upload that. The other beazle for same thing really with the LCD panel. LCD I2C, I think I found on Thingiverse. There's people that have done boxes. I didn't want it as thick as that. That's pretty close, but there's a box here. Basically in the end nothing worked. I needed it to cover over that really, because the LCD comes with a beazle already, but it won't flush panel mount for a number of different reasons. But anyway, so it doesn't lip, it just sticks through, and then obviously that leaves when you cut out the panel plastic, it leaves a mess unless you're laser cutting it. So anyway, with that one I started afresh really, and did it as thin as possible, similar design to the GCA 901, and then the little inside lip here so that it would clip over the top of the LCD and hold it in place. That was a fairly simple one, that one, compared to the other one. But yeah, it works. Oh, there we are, there we go. There's the box fascia, sides drilled and got all their fittings in. Which looks rather neat and nice. Well, I think so anyway. I hope you like this video. Obviously it's part of a set of videos of me building this greenhouse controller version 2. The next video will be, I think, just building it, really, doing all the internal parts and getting it going, really, getting it tested, and then finally I think we'll install it. So yeah, any comments, questions, please do leave them down in the comments below. Happy to answer them. And look back at the other videos. I put them on a playlist actually, because there's a few videos on this series now. I hope you enjoyed the video, and I'll see you in the next video very soon. Bye for now.